Thank you. OK. So I'm Thomas Duprier, PhD student, and I'm going to present a debugging API. Yep, let's go. So here's the plan. Introduction on debugging. Then we're going to present our solution to the resource question we'll have previously stated. Then the fun part, I'm going to walk you through the key features of Sindarin with examples. Evaluation. Then a few MISC stuff, interesting stuff, note, you can do with Sindarin, and conclusion. OK, so debugging. It's time-consuming. So as this study by the Judge Business School of Cambridge has shown, on average, 50% of the time of software development goes into debugging, so quite a big deal, which makes it expensive because if half the time goes into it, while half the budget goes into it, that's a lot of billions of dollars per year. But it can be fun if you have the right tools. If you don't, it's a pain, usually. So on the topic of tools, you have some sort of spectrum. So on the one hand, you have your general-purpose debuggers. On the other hand, you have specialized debugging solutions. Obviously, general-purpose debugger, it's always usable. It's basically what you find in your IDE. But it's sometimes tedious to use for challenging or domain-specific debugging tasks. So it's general purpose. It's not specialized. And on the other end of the spectrum, you have specialized debugging solutions that are really good at one thing or a few things. But then what if they don't exist for what you want to do, or you need something different? So what we want to do is something in the middle that has the advantages of both worlds. Something always usable and something that still has power to tackle specific problems. And we believe that a debugger API has this potential, which leads to our research question being, what is a debugger API that is versatile enough to allow developers to perform many debugging tasks, but without requiring multiple specific debugging tools or tedious manual operations? Because technically, you can do everything because it's computer science, Turing complete. But sometimes it's just too tedious to actually do it. OK, so our answer is the Sindarin Debugger API. So this diagram shows the base. So you have your normal debuggers. And within Sindarin, you write scripts that control the execution you want to debug, for example, to bring it to a certain point. And we implemented this API on the Pharo language, so a variant of Smalltalk. And to answer this question before going anywhere else, can it be applied to another language? Yes, it's an API, so it's language agnostic. You can implement it, but you need something to provide some things, 3 things actually. Step granularity at the expression level, so as opposed to line level, for example, like step to the next line. Here you want to step to the next piece of the expression. Full context access, so you need to have access to the whole context stack with all the stack frames. And in each of these stack frame, you need to have access to the value stack, on which are put the intermediate values of the expressions that are being evaluated. And you need to be able to read and write these stacks. And finally, an AST-mapping, so that you always know where you are in the AST. OK, so this is the methodology part. Here, without going into detail, we took a set of debugging scenarios of things people do with their debuggers. So some of them are from personal experience. Others are from research papers. Sorry. And for each of them, we examined which features they require among the 3 I listed before. So some of them need very fine-grained granularity. Some of them only need like really coarse-grained stepping. Same thing for the context access. So what I mean, the difference between basic and stack access is that, so basic is when you have access to the context stack and the don't remember, oops, skip. when you have access to the context stack, and when you have full access to it, you can pop and push values from the value stack of the context. That's not really what I want to focus on. And also, we are not alone. There are other debugger APIs. If you're looking for GDB, it's part of this, what we call unmanaged code debuggers. And same thing, we looked at them and looked at which features they implement. And here you have Sindarin, where we have everything. Ooh. OK, now the fun part. So these are the 6 key features I want to show with examples. So the first one is stepping. It's like there is nothing magic here, but it's to get started. On the right side, there will be, for each feature, a card with subtract of the API to give an idea of what it looks like. And every time there will be a goal. So here it's a very naive goal. I want to step 15 times in execution and then skip the next instruction. The idea being skip is that if you're about, I don't know, to call a method, if you skip it, then you don't call the method and you keep going with a value you decide. You say, well, no, don't do this. Oh, it's worth that. Trust me. And the execution keeps going. Every time there will be a Sindarin script to address the goal. So here, well, we tell our debugger to step 15 times, and then we tell it to skip. Very simple. For the syntax highlight, our debugger object is in purple, our API is in blue, and literals are in green, and the rest is in black. Simple. And for every slide, there will be a little card in the bottom left showing which features we use. So here we use step granularity, but we don't access the context, and we don't use the AST-Mapping. OK, this was the simple one. So AST-Mapping, now we don't want to blindly step the execution and hope we get to the right point. We want to control a bit. So we want to step until we're about to send a message or call a method. The two terminology exist. And then skip it. So we write something like this. Oh, step until the node I'm on is a message, and then skip it. So the AST access comes here because we request, hey, on which node am I? And that's why we have AST mapping here. Next feature, context access. So this one is a bit more to it. Here we want to step not anywhere. We want to step until an instance of a given class of your choice is about to send a message and then skip it. So we write something like this. We step until, well, the node is a message, the same thing from the script earlier, but also if the receiver of the current context is a my class. And then we skip. So here we use basic context access. Again, helper methods. So it's not, you could argue it's not technically a feature, but because helpers are not features in themselves. But I would argue that an API needs to be convenient, and that's the whole point of this API is to provide something that's convenient. So helper methods are definitely a big part. Here, what do we have? Yeah, step until we're about to signal this exception, division by 0, and then skip it. So you may wonder why would someone want to do this? Well, you're debugging, so you want to get information from your execution, like how things happens, to then be able to fix the problem. You already know, like oh yeah, I know this piece of code sends a signal, a division by 0. I want to know what happens after. So like I know maybe does it trigger a second time, a third time? I'm getting information here, so just let me proceed the execution. We write something like this. So I step until I'm about to send the message signal, which is the signaling of an exception, to the exception I'm interested in, and then I skip. And on this slide, I have a second goal. So I want to step. Let's say I'm interested in the value of a given variable. I want to step until I'm about to assign something to this variable. So I write something like this. I step until I'm on an assignment for a variable named the name of the variable. This is kind of like a watch point, basically, if you're wondering. Obviously, you can do more than that with Sindarin, but this gives you an idea, like we have a watch point in 3 lines. Not bad. OK. Second to last feature, breakpoint manipulations. So we can manipulate breakpoints from Sindarin. So here, we were interested in division by zero exceptions. So now we want to set a breakpoint whenever this happens in execution, but also to be able to traverse the execution afterwards. We want that whenever we hit one of these breakpoints, we skip the exception that comes after so that we can proceed and not get stuck at the first exception. So we write something like this. Until the execution finishes, we step until we're about to signal division by zero. Then we set a breakpoint, and we program this breakpoint to say, hey, when you're hit, skip the next instruction. And this is the interesting part. We can program the breakpoints to do stuff when they're hit. And if you write a script like that, afterwards you get an execution with breakpoints on the relevant parts, and you can run it, and it stops, and then this division by zero happens here. Okay, and proceed. Oop, you get to the next division by zero. Proceed. All right, and the last part, last feature, object-centric debugging. Without going too detailed, because that's a debugging field in itself. The idea is that you debug a specific object, not all the objects of that class, but this one. And what's cool with Sindarin is that you can capture the object in question easily and then do things to it. So here we want to step until, this object receives a message, not another instance of the same class, this one. We write something like this. So here, let's say the object we're interested in is the first instance of my class we encounter, for example. Well, we step until we're on the my class. We store the object in a variable. So now this is one object. And then we say, hey, halt next time you're called. And then we proceed, and it will halt the next time this object is called. And finally, for this section, a bigger example and a bit more concrete. So here, I have a program. It operates on some files. It opens files, do those stuff. But then at some point, it reopens a file that already opened, and so it crashes. Now, I'm interested to know, obviously, I get the stack trace of the second file opening, because that's where it fails. But I'm interested in the stack trace of the first time it opened the problematic file. Because I want to know, hey, when did this happen? Why did it open the first time? So I write a script like this. First line, I create a dictionary in which I'm going to store stacks. And then I run the entire execution. I step until I'm about to open a file. And then in the stack of dictionary, I looked at message receiver. So the message I'm about to send is open to an instance of file. So the receiver of my message is the file I'm about to open, or the object representing the file I'm about to open. I put this in the dictionary, and if there is nothing there, well, I put a copy of the current stack. If there is something there, then I return the stack I just found, because that means I already opened this file, and it's about to crash, and I want the first stack. Here, the semantic, I return the stack, which means the script stops, and it returns you the stack, and you can do things with it. And and I have a step here, because obviously, if you don't put a step here, you step until you're here, you do stuff, you put stuff in dictionary, and then you step until, well, I'm already on file opening, so you would loop endlessly. So that's why you have one step to just go, just proceed. OK. And that's essentially what I just said. So, OK, that's interesting. Disregard this for now. So the evaluation, we looked at multiple debugging scenarios from the literature, and we tried to implement them in Sindarin. So each of these paper, here I have, now it's complete. Each of these paper finds a problem, like, oh, I have a problem with, I don't know, specific problem, and then devise a specific solution for this problem. And what we want to show is that Sindarin is versatile, meaning we can implement each of these specific debugging solutions in our API, and to have everything without having to download this thing and this thing and this thing. This one is a bit special because it's a PhD, so it's a bit bigger. We used it because there are a bunch of debugging scenarios in it. OK, so first scenario I'm going to talk about, control flow breakpoints. The goal is, on each of the slides I'm going to show, There is the goal in letter forms, and there is a diagram showing the same thing with pictures and the reference to the paper in question. So here, I want to stop the program at a given method. That's easy, but I don't want to stop if it's called by that other method. So in diagram form, I want to stop on method when method A is called, unless it's called by method B. So if method B calls method A, I don't stop. If anything else calls method A, I stop. I'll write something like this. Well, I step until I'm on method A, and my sender is not method B. And then I run the script, and this magic happens. And this is so obvious. In this script, I just look at the previous sender, but I could look at the whole sender stack. So I could, like, if method B is present in my sender stack, then I don't stop. Stateful breakpoints. So here I have a sequence of breakpoints, and I want them to trigger only if they're encountered in the right order. I put breakpoints here between, I don't remember the name, because they don't break when you hit them. You don't want to break when you reach method A. You want to break when you've reached all these methods in this order. So they're not really breakpoints. They're points. They don't break. So I write something like this. I have the list of methods I'm interested in. So here a method A, and then a method B, and then et cetera, and then method X. And then they'll do, hey, for each of these methods, step until I'm on this method. So I step until I'm on here, and then I step until I'm here, and then blah, 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 and then I step until I'm here. The script finishes, and the execution is stopped. And there I am at the point I wanted to reach. And my last example, monitoring assignments to a variable. So, okay, there is no graphics. I want to stop the execution when a given value is assigned to a given variable. Well, I write something like this. Step until I'm about to assign something to this variable, and I'm on this class, and the value is this. So here I step until I assign 42 to the foo_var variable of the class, my class. This is on the simple side. What you could want to do, for example, is to list all the values this variable goes through during the execution. So you would add an array, like declare an empty array, and then whenever you are in this variable, you could store the value, the assignment value, in the array, and then proceed. And then you get a list of all the values this variable goes through with a few lines of script. Okay. So now the bonus part, what I like to call the bonus part, and what my advisor like to call applications. We can use Sindarin to integrate all these solutions in your debugger. So here is the graphical debugger of Pharo, and this is our prototype. So we added, these are the step commands you're probably familiar for, like step over, proceed, these kind of things. And here we have a button, new command. If you click on it, we have this form. We can write the Sindarin script we want, and then create. And now our debugger has one more button that does the script we just wrote. So that means you can add commands to your debugger that are specific to you. For example, if you want a command that steps until you're on an instance of the file class, then you write this, and then your debugger has this button, which means you can build tools that are specific to your program or your domain. Another thing that's cool is that once you have a Sindarin script, you can do stuff, you can do more with it. You can turn it into a test, for example, because when you have, let's say, written a script to reach a point in execution and check something like the values of a variable, well, that's a test. You take the script, put in a test with an assert, and bam. You can help other people when you're not working alone in your cave. If you write a smart script to reach a place, then you can give it to other people so that they can also reach that place. Or if you devise a smart operator that goes to the next, I don't know, file opening, then you can give it to other people. And finally, you can attach them to issue tracker. So again, if you write a script to reach a point, if you give that script to the person that's going to debug your issue, he's going to be really happy because he can just get to the point, the problematic point. And on this subject, you could automatically generate Sindarin scripts from the interaction you have with your debugger. So we could record, oh, he clicked that button and then that button and then switch to that context. Well, we could record that and generate a Sindarin script from it. So you can say, hey, give me whatever I did with my debugger, and do it again. Or send it to that person. And finally, this is an open research question, so I don't have the answer. But that's something we're going to tackle next. What's a good design for debugger API? What does it even mean to be good for this purpose? OK, and on that, this is my conclusion slide. So this is what we've done. Some debugging tasks, general purpose debuggers, they're cool, they work all the time, but some tasks are hard to perform with them. Specific debugging tools, they solve specific tasks. We want to merge them, so we propose an API in which you can implement the specific tools. So you have one API instead of multiple tools, and which allows you to write domain-specific script on the fly. Like, oh, I need this, and get there. I write it, execute it, and bam, I'm there. And to evaluate that, we successfully implemented multiple specific debugging tools from the literature using Sindarin. The code of the implementation for Pharo is available on GitHub. Thank you.
So you make the claim that you can use these scripts to build domain-specific debugging operations, but you haven't showed that yet. So, for example, you mentioned in your paper that you think that you could implement a moldable debugger with this approach.
Yep.
But have you tried it yet, for example, to build a specialized debugger for a parsing tool or parsing rules?
That's the next. That's the thing. I'm like, I go back next week and I do this.
So what are you going to start first?
I wanted to look into an answer systems because it quickly gets hairy when you have tons of subscriptions everywhere, and I wanted to maybe like I can simplify something and like step 2 next time this event gets triggered, or is this event ever triggered during my execution? I question like answer questions like this with buttons like, is this ever called? Is this ever triggered? Bam, tell me true, false. So that's my first candidate for a try.
We said nothing about debugging of multi-threaded applications. Why?
Because here we're because we're debugging single. So obviously, yes, this is I was waiting for this question. Because obviously, so we're working on single-threaded for now. And yeah, concurrency is on the back burner for now. Like it's the next thing, one of the next thing we're gonna do. But it's probably going to bring interesting challenges because it becomes much harder to say like, oh, this part of the execution is running and this part is stopped, and like how do they block each other, this kind of thing. So yeah, there is material for research there, definitely.
So does your implementation work with multi-threaded applications, or it's only
if it does, I'm not aware of it. So I guess it doesn't.
You may be interested in some previous work presented at DLS, 2016? 2017? There was a paper on how to make debugging language agnostic and support concurrency.
Have you thought about simplifying debugging embedded applications? In most cases, they're single-threaded, and it's quite difficult to debug them with visual debuggers.
About simplifying what applications?
Debugging embedded applications. It means applications which run on microcontrollers or some devices without display, or etc.
I have not. I know someone in my team is doing this kind of thing, like IoT, debugging IoT things. So, but I mean, I should talk to the guy next door. Hmm? Yeah.
Because the current model of scripting and execution is a good fit for debugging such scenarios. So you just yeah, stop what usually in embedded world try to do something like scripting.
Yeah, that's one of the idea with, because if you notice, the name of the paper is Sindarin API. We're not selling the Pharo implementation. We used it obviously as a way to validate it, but we're selling the API. So the idea is that it should be implementable in other languages. Obviously, the way you will implement this feature is going to change, because not all languages provide the same things. Some have VMs, some have not, and they don't have the same reflective layers and this kind of thing. But one of the goals is to be language agnostic in the API itself, and then implement it with different backends on different languages.
I will basically repeat the previous question because you dodged it. Do you have any plans of re-implementing Sindarin for, I don't know, to work with VS Code or anything else?
For a foreseeable future, no.
Okay.
I think I will chime in into this. I think really the incredibly interesting idea is that this is an API, and even inside Pharo itself, there is a lot of different work going on in the debugger, like Jan Van's integration with GDB and my own QLE, universal-like debugger, and a bunch of other stuff. It's so fragmented that I think at this point we really need an API that can bring all of these things together. Because to answer the question of embedded things, you can talk to an embedded target using the GDB remote serial protocol, either with Jan-Van's or with mine, but it doesn't integrate with anything else. So it's a critical time for discussing what was on the previous slide. What is a good design for an API that can bring together the metaphysics debugger and the ULT debugger and the GDBS debugger and so on? They are all small-talk debuggers, and they cannot talk to each other. It's a lot of repetition and wasted effort.
Okay.
We need to discuss this offline.
I would take other questions offline and let say
Yep.
Thomas again.
Thank you.